Welcome students, welcome to the ninth lecture of Model 2, Pumps and Actuators. So today we are going to start with the discussion regarding the actuators. Okay, so what is this actuators? Actuators andre ಏನು? So if you see the whatever the circuit of hydraulic system, so or else you are going to see the pneumatic systems. So the final device which you are going to see, okay, so ಈಗ ಹೈಡ್ರಾಲಿಕ್ ಸಿಸ್ಟಮ್ ಇರ್ಬೋದು ಅಥವಾ ನ್ಯೂಮ್ಯಾಟಿಕ್ ಸಿಸ್ಟಮ್ ಇರ್ಬೋದು, ಅದರಲ್ಲಿ ಒಂದು ಫೈನಲ್ ಒಂದು ಡಿವೈಸ್ ಇರುತ್ತೆ. ಆ ಡಿವೈಸಿಂದ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪೆಕ್ಟ್ ದ ಮೆಕ್ಯಾನಿಕಲ್ ಔಟ್ಪುಟ್. Okay, you are going to expect the or extract the mechanical output. So that device which is converting the fluid power into a mechanical output in the form of force or motion is called as actuators. An actuator is used to convert the energy of fluid back into the mechanical power. Okay, so it is going to convert the energy of fluid again back into the mechanical power. So primarily what happens in the fluid power systems, the fluid which is in static condition, it is going to be converted, means it is in a static stage. The liquid is going to be transmitted and it attains the dynamic condition by the whatever the action of pumping. So pumping ಇಂದ ಏನಾಗುತ್ತೆ, liquid dynamic state convert ಆಗುತ್ತೆ. So because of that dynamic state, the liquid gets some pressure. Okay, it gains some pressure. So that pressure energy is going to be transmitted from one point to the another. So that pressure energy is going to be harnessed. It should be taken for some useful work. So that conversion of that fluid power into a mechanical power is done by the actuators. The amount of output power developed depends upon the flow rate. Flow rate, pressure drop across the actuators and its overall efficiency. So it's mainly depending upon flow rate, pressure drop and the overall efficiency of the actuator to determine the performance of a actuator. Thus, hydraulic actuators are devices used to convert the pressure energy of the fluid into the mechanical energy. The fluid power is going to be converted to a mechanical power by means of force or movement by using the actuators. So actuators, hydraulic actuators are classified into two types. One is linear actuators, another one is the rotary actuators. So linear actuators ಅಲ್ಲಿ ಏನು ಯಾವುದಕ್ಕೆ ನಾವು linear actuators ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ ಅಂದರೆ, the motion which is expected from the linear actuators is in a straight line. Okay, so linear actuators ಇಂದ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಒಂದು ಸ್ಟ್ರೈಟ್ ಲೈನಲ್ಲಿ ಮೋಷನ್ ಸಿಗುತ್ತೆ. ಅಂದರೆ ಈಗ ರೆಸಿಪ್ರೊಕೇಷನ್ನು, ಲಿಫ್ಟಿಂಗು, ಓಕೆ, ಸೊ ಆ ಒಂದೇನಿದೆ ಸ್ಟ್ರೈಟ್ ಲೈನಲ್ಲಿ ಏನು ಮೂಮೆಂಟ್ ಇರುತ್ತಲ್ಲ ಅದನ್ನು ನಾವು ಲೀನಿಯರ್ ಆ್ಯಕ್ಚುಯೇಟರ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ರೋಟರಿ ಆ್ಯಕ್ಚುಯೇಟರ್ಸ್ ಅಂದರೆ ಯಾವ ಥರ ಅಂದರೆ, ದಟ್ ವಿಲ್ ಮೇಕ್ಸ್ ದ ಆಸಿಲೇಟರಿ ಮೂಮೆಂಟ್ಸ್ ಆರ್ ರೊಟೇಷನ್ ಮೂಮೆಂಟ್ಸ್. ಸೊ ದಟ್ ಈಸ್ ದ ಔಟ್ಪುಟ್ ಮೂಮೆಂಟ್ ವಿಚ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಒಬ್ಟೈನ್ಡ್ ಫ್ರಮ್ ದ ರೋಟರಿ ಆ್ಯಕ್ಚುಯೇಟರ್ಸ್. ಸೊ ರೋಟರಿ ಆ್ಯಕ್ಚುಯೇಟರ್ಸಿಂದ ನಾವು ರೊಟೇಟರಿ ಮೂಮೆಂಟ್ ಎಕ್ಸ್ಪೆಕ್ಟ್ ಮಾಡ್ಬೋದು ಅಥವಾ ಆಸಿಲೇಟರಿ movements can be expected from the rotary actuators. So linear actuators, we will discuss regarding the linear actuators. In hydraulic system, hydraulic linear actuators, as their implants provide motion in straight line, they are usually referred to as cylinders, rams and jacks. You can see the examples for this linear actuators. The main examples are cylinders, rams and jacks. So cylinders reciprocate in one line, rams is also going to move to and fro in one line, and jacks is also going to lift the load in one direction. Okay, so like that the operations are going to be taken place in the linear actuators. The function of hydraulic cylinder is to convert the hydraulic power into a linear mechanical force. The hydraulic cylinders extend and retract a piston rod to provide a push and pull force to drive the external load along the straight line path. That we have understood from this what are the linear actuators. So we have some types in the linear actuators in the hydraulic cylinders. Okay, so we know hydraulic cylinders are one of the type of linear actuators. We have some types in the hydraulic cylinders because there are many types in the hydraulic cylinders. There are single acting cylinders, double acting cylinders, double rod cylinders, tandem cylinders, telescopic cylinders, cushioned cylinders. These are the type of cylinders which are going to be considered in the linear actuators under cylinder section. So first we will see the single acting cylinders. Single acting cylinders yav ತರ irutte. We will see the first construction. Okay, the single acting cylinders consisting of one single cylinder, one input and output port which is present at here. The input and output takes place in a single port. One piston is provided with piston seal for to avoid the leakage between the gaps of the cylinder. Next, the piston is connected to a piston rod which is going to reciprocate it to and fro, and the piston lower end of the head is going to be connected to the spring. You can see the spring in here which is connected to the cylinder block at the end. This whatever. So in this single acting cylinder, if you see the operation, it is mainly with respect to the action of this fluid and the spring. Okay, so as the fluid enters in here, it will create the pressure. Okay, the pressure increases at here and it will pushes the piston to move right side. Okay, the piston is going to be moved right side because of the fluid pressure. So when the fluid pressure is going to be increases, it will intense pushes this piston, and this spring which is connected to this whatever the piston head, it will get contracted. Okay, it will get contracted, and because of the contraction of this spring, it will stores the energy. Okay, it is going to store the energy. So as the piston move to the this whatever the rightmost portion, the maximum energy is going to be stored in the spring. Okay, and the maximum extension stroke is going to be achieved. At the second stage, at the retraction stage, what happens? The liquid which is present at here, it will be again pushed back. It is going to be sent back to the tank or reservoir through this same port while the operation of direction control valves. Because of the extension of the spring, the pressure is going to be exerted on the piston, and piston intends to exert the pressure on the fluid. Because of that, the liquid is going to be transmitted again back to the tank or reservoir. Okay, so like that, this operation is going to take place in the single acting cylinder. The one small port is provided here to remove the excess air or trapped air which is present at this portion while the retraction stroke. Okay, so like that, it is going to be takes place in this whatever the single acting cylinder. You can see the video in here. So this is the direction control valve. Okay, the direction control valve will supplies the liquid input, and it will again direct the liquid to move outside. Okay, so like that, the whatever the motion is going to be expected in here. So as the liquid enters here, the piston moves forward, and as the liquid directions changed, the liquid again going to be supplied back to the tank. So this is the input port, this is the return port to the tank. So like that, the operation is going to take place in the single acting cylinder. We will see the double acting cylinder. The construction of this whatever the double acting cylinder is very much similar to the single acting cylinder. Only the change is you will find the two ports. Okay, so you can see there are two ports presented here. So it is not actually the air port. The whatever the in here in the single acting, they were provided one vent for the air vent for to expel the air, but in here it is not for the expelling of air, it is to supply the liquid. Okay, so in here also you can see the cylinder block, the hatched portion will show this the cylinder. So then piston, so piston is going to be provided piston seal. Okay, the liquid first in the extension stroke, the liquid is going to be supplied inside this whatever the through this port. The whatever the liquid is going to pressurizes the piston to move right side. Okay, it will pressurize the piston to move right side. So the liquid which is trapped at here, it will be sent back when it is moving to the right side. The liquid is going to be sent back to the tank or reservoir. In the next stage, in the second stage, you can see here in the return stroke, the liquid is going to be transmitted from this port. Okay, plus the input is going to be takes place at here. The liquid will be filled in this gap. It will pressurizes the piston to move left side. Okay, according to this diagram, it will tends to force this whatever the piston to move left side, and whatever the liquid trapped at here or filled at here, it is going to be, because of the pressure of this piston, it will expelled out through this port to the reservoirs. So like that, the extension stroke and return stroke are going to be carried out in this double acting cylinders. You can see here, there is a video. At the input, the liquid pressurizes the piston, it will move forward. In here, the liquid is going to be expelled out while forward stroke. But when liquid is transmitted through here, the piston moves in this direction and it will express the whatever the liquid which is trapped at here. So like that, this reciprocation process takes place in the double acting cylinder because of the fluid power. Okay, you can see in this portion the area of liquid for the pressurizing the piston is more compared to this area. So because of that, the some amount of pressure variations will be expected in the both ends of the piston. Next we move on to the double rod cylinders. Okay, so double rod cylinders are nothing but the piston is provided with the rods at the both ends. You can see the in here there is a cylinder block, there is a piston, a single piston which is present at here, which is connected by the piston rod at the both ends of this piston. Okay, then at the both ends of the piston is connected with the piston rods. So what happens, and you can see there are two ports at the section. If you consider the extension and return stroke, the extension stroke, the liquid will be supplied here, the piston move right side, and in here in this rod the extension stroke happens, but in this rod it will make the return stroke. Similarly, the liquid is going to be transmitted from this port. It will pressurize in this direction and it will make the extension at here and retraction at here. So like that, so if you want to make a simultaneous operations in some application, okay, some applications having the two operations simultaneously, it should be done in here. So such application area you can use the double rod cylinders. So that is the one of the type in here you can that is used for the different applications. So you can see the video. So liquid is transmitted from here, then the liquid is going to pushes the piston right side. If the liquid transmitted here, the liquid will be pushed at the piston to the left side. So both means if you have the operations at the both ends, that can be carried out by this double acting whatever the rod cylinder. Next is the tandem cylinders. So tandem cylinders ಅಂದ್ರೆ ಏನು ಅಂದರೆ ಈಗ ಒಂದರ ಹಿಂದೆ ಇನ್ನೊಂದು ಅಂದರೆ ಬಾಲ ಅಂತ ಹೇಳ್ತೀವಿ ನೋಡಿ, ಒಂದಕ್ಕೆ ಇನ್ನೊಂದು ಬಾಲ ಕನೆಕ್ಟ್ ಆಗಿದೆ ಅಂತ ಹೇಳ್ತೀವಲ್ಲ, ಲೈಕ್ ದಟ್ ಎ ಟೆಂಡಮ್ ಸಿಲಿಂಡರ್ ವಿಲ್ ಬಿ ದೇರ್. So it is connected, the one piston rod is connected to the another piston rod, but there is some what is the restriction between, there is some blocking between the two piston operations. Okay, so you can see the two, you can also say it, the two cylinders are going to be connected in this way. So each cylinder having two ports, one inlet and outlet. Similarly, this one is having the inlet and outlet. It will interchanges when the direction control valve direct the fluid. So in this tandem cylinder, what happens? This is mainly used when there is a double amount of force is required. Okay, so for to increase the amount of force is required. If you use only single piston cylinder, what happens? Only one pressure is going to be applied here, and the amount of force is going to be with respect to this amount of pressure. But if you expect if you want more amount of force output, so what you have to do? You have to increase the pressure at here. But there is some limitation for one cylinder. You can't cross that limit to increase the pressure. But if you want to increase the pressure, by another way, you can use this tandem cylinders. So if you have the two pistons, the two ports will supply the fluid at these two ends Okay, so because of that supply, the pressure builds up at here and pressure also builds up at here. So because of the pressure which is twice, okay, or you can consider more than one, okay, the pressure is going to be increased here. So because of that double pressure, the piston is going to provide the force which is higher than the single piston force. So because of that, the tandem cylinders are the cylinders which are mainly used where the higher amount of force is required. Okay, so in such areas the tandem cylinders are going to be used. Only one drawback of this tandem cylinder is the length of cylinder is going to be considered as doubled. The length of cylinder is going to be more, so while comparing the single cylinders. So that is one of the drawback compared to the other type of cylinders. You can see the operations on here. The two pistons are reciprocating and only one to and fro motion expected at the whatever the this end. So the pressure is going to be high, okay, and because of that the force is going to be considerably high in this whatever the operation of tandem cylinders. So next we move on to the cushioned cylinders. The cushioned cylinders are very important. Why? Because cushion cylinders are mainly used to protect the cylinder caps. Okay, to cylinder end caps, we require the cushioned cylinders. What happens as the piston reciprocates? Piston reciprocate ಆಗ್ತಿದ್ದಾಗ ಏನಾಗುತ್ತೆ, ತುಂಬ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ತುಂಬ ಪ್ರೆಷರ್ ಇರುತ್ತೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಇಟ್ ವಿಲ್ ಫೋರ್ಸ್ಲಿ ಹಿಟ್ ದಿಸ್ ವಾಲ್ಸ್. Okay, it is going to hit the wall of this whatever the cushioned whatever the cylinder ends. Cylinder ಎಂಡಿಗೆ ಏನಾಗುತ್ತೆ, ಫಾಸ್ಟ್ ಆಗಿ ಬಂದು ಹಿಟ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ದ ಶಾಕ್ ಲೋಡ್. ಸೊ ಶಾಕ್ ಲೋಡ್ಸ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗೋದ್ರಿಂದ ಸಿಲಿಂಡರ್ಸಿಂದು ಲೈಫ್ ಕಮ್ಮಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಹೌದಾ. ಸೊ ಲೈಫ್ ಕಮ್ಮಿ ಆಗುತ್ತೆ, ಮತ್ತು ಈ ಸಿಲಿಂಡರ್ ಲೈಫ್ ಕಮ್ಮಿ ಆಯಿತು ಅಂದರೆ ಆಟೋಮೆಟಿಕಲಿ ದಿ ಆಪರೇಷನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಸ್ಟಾಪ್. Okay, so that is the problem which we are going to expect. So to avoid that problem, we are using the cushioned cylinders. So cushioned cylinders are nothing but the piston slowly ends at the okay, the piston will fastly move at this point, but from this point to this point the piston moves slowly. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಬರ್ತಾನೆ ಏನಾಗುತ್ತೆ, ಪಿಸ್ಟನ್ ಸ್ಲೋ ಆಗುತ್ತೆ. ಪಿಸ್ಟನ್ ಸ್ಲೋ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಸ್ಲೋ ಆಗಿ ಅಟ್ ದ ಎಂಡ್ ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ರೀಚ್. ಸೊ ಆ ಸ್ಲೋ ಮೂಮೆಂಟ್ ಆಗೋಕ್ಕೆ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಡೂ. So in here you can see the construction of this cushion cylinders. This is the output of a liquid. Okay, this is the output of a liquid, but you are not providing the output of a liquid directly. So you can see there is a piston in here. The piston is provided with the plunger enters the, and it is going to enter here in a small gap. Okay, the plunger first enters here in a small gap. So when it enters in here, so the liquid which is trapped in this whatever the plunger, in front of plunger, it will pressurizes to this whatever the check valve. There is a check valve provided here. The check valve ball, you can call it as a ball valve. The ball opens in here, the liquid transmitted here, and it will come to this direction. It will come in this direction. It will pressurizes the fluid in reverse direction. It will pressurizes the piston in reverse direction. The piston experience that pressure and it will slow down its motion. ಓಕೆ, ದ ಪಿಸ್ಟನ್ಸ್ ಏನಾಗುತ್ತೆ, ಈ ಲಿಕ್ವಿಡ್ ರಿಟರ್ನ್ ಹೋಗಿ ಪ್ರೆಷರೈಸ್ ಆಗೋದ್ರಿಂದ, ಯಾಕಂದರೆ ಇಲ್ಲಿ ತುಂಬ ಪ್ರೆಷರ್ ಇರುತ್ತೆ, ಸೇಮ್ ಪ್ರೆಷರಿಂದ ಇಲ್ಲಿ ಬಂದು ರಿಟರ್ನ್ ಆಗಿ ಪಿಸ್ಟನ್ನಿಗೆ ಅದು ಸ್ಟಾಪ್ ಮಾಡುತ್ತೆ. ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಪ್ರೆಷರ್ ದ ಪಿಸ್ಟನ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟು ಮೋಷನ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ಸ್ಲೋ ಡೌನ್ಸ್. Okay, that is one reason in here, in this direction. In other direction, what happens, the liquid trapped at here, it will move in a small gap. So because of that small gap will be maintained by this adjustable screw. You can see this is a screw, this is adjusted. So if you adjust the gap, the liquid going to enters it here in a small gap. So if it is reduced, the liquid moves slowly and it will restrict the piston to move fastly. So by that the cushioning effect can be experienced at the end of this piston. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಪಿಸ್ಟನ್ ಜೋರಾಗಿ ಬಂದಿರುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ ಆ ಒಂದು ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರೋದ್ರಿಂದ ಪಿಸ್ಟನ್ ಸ್ಲೋ ಆಗಿ ಅಟ್ ದ ಎಂಡಿಗೆ ರೀಚ್ ಆಗುತ್ತೆ. ಸೊ ಆ ಒಂದು ಕುಷನಿಂಗ್ ಎಫೆಕ್ಟಿಂದ ಏನಾಗುತ್ತೆ, ದ ಸಿಲಿಂಡರ್ ಬ್ಲಾಕ್ಸ್, ಆ ಸಿಲಿಂಡರ್ ಎಂಡ್ ಕ್ಯಾಪ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಪ್ರೊಟೆಕ್ಟೆಡ್ ಆ್ಯಂಡ್ ಇಟ್ ವಿಲ್ ವರ್ಕ್ ಫಾರ್ ದ ಲಾಂಗರ್ ಪೀರಿಯಡ್. ಸೊ ಫಾರ್ ದಟ್ ಪರ್ಪಸ್ ಓನ್ಲಿ ದ ಕುಷನ್ ಸಿಲಿಂಡರ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಬಿ used in the industrial purpose. When the cylinder piston is actuated, the fluid enters the cylinder port and flow through the little check valve so that the entire piston area can be utilized to produce the force and motion. For the prevention of shock due to stopping loads at the end of the piston stroke, cushioning devices are used. Okay, so the same thing I have explained you. You can see the video. Sorry, there is no video in here. So I will show, if you want to see that video, just a minute. You can see here the cushioning is going to be expected at here, the pistons motor, but is slowly moved at the end. So like that, this process is going to be considered for the cushioning application. So like that, whatever the cushioning is going to be expected in the cushioned cylinders. So next, last one is the telescopic cylinders. Okay, you can see the telescopic cylinders are nothing but it is a set of cylinders. Okay, it is a set of cylinders which are aligned inside bigger cylinder. You can see this. There are the many cylinders which are provided at here. Okay, you can see it have the multiple cylinders that are mounted concentrically one within the another. Okay, it is mounted concentrically one within the another. So what happens, it is the cylinders, it is having the multiple cylinders which is mounted concentrically. So all the centers of the cylinders are same, it is mounted one within the another. So you can see one cylinder, 2, 3, 4. The 4 cylinders are concentrically mounted within each other. So like that, this whatever the telescopic cylinders are going to be made. The design is such that innermost cylinder extends first, while the next cylinder extends after the completion of the full stroke of the cylinder. Thus, each cylinder extends in stage one after the another. So what happens? The innermost, this is the innermost cylinder. This is the outermost cylinder. The liquid enters here. When the liquid enters, it will pressurize the innermost cylinder and it will pushes the innermost cylinder first. So when the innermost cylinder extends fully, then second cylinder is going to extend it. So like that, one by one, the each cylinder is going to extend and it will make whatever the extension stroke in here. You can see the video in here. The first liquid is going to enter in this port. Okay, you can see here. The liquid enters here. It will pushes the first inner cylinder, next second cylinder. So like that, the telescopic action is going to take place in the telescopic cylinders. Each stage of the cylinder have the sleeve that fits into the previous stage of the cylinders. So the sleeves are provided at the end. These are the sleeves. So it will fit at the end of the whatever the stroke of that whatever the each cylinders. The total stroke length achieved will be sum of the strokes of the all stages. So if you want to determine the total stroke, you have to sum up all the strokes of the each cylinder. Okay, so this is all about the actuators in cylinders. Okay, in a linear actuators, the diagrams are very important as per the examinations. You have to explain with a neat diagram and a clear procedure. Okay, if you have any doubts, you can contact me through my contacts. Okay, thank you for watching.